In Unit 5, we are going to be looking at solving systems of equations and eventually inequalities. We're going to start with systems of equations. So what this is two or more equations with the same variables. And what happens is you are solving them at the same time. So usually you can only have one variable that you're solving for. This is going to show us how we can solve for two separate variables in the same problem. We will only do two at a time, but it is possible to do more than two. So we're going to learn three different ways. The first way is that we are going to learn to solve them by graphing. When you're doing that, you're looking for the spot where the two lines intersect, where they cross each other. When you solve it algebraically, you're looking for the ordered pair that makes both equations true. Now you can still check your answer with your equations even if you graph it, and we'll show you that as we move along. So what you will have is you'll have two different equations that you're graphing. So three different things can happen. You can have two lines that intersect. So you'll graph a line and you'll graph another line and you'll look for the spot that they intersect. So if they intersect one time, you are going to write an ordered pair, x comma y, where they intersect. You do not have to write the one solution. You just write the actual numbers. The other thing that could happen is you have parallel lines. Those lines will never intersect. So what that means is you can find no numbers to plug in to make both equations true. So you can either write out the word no solution or you can put a 0 with a slash through it. The last thing that could happen is you could actually end up graphing the same exact line. You don't have to draw it twice, but you can if you want, if that helps you realize that you are graphing the same line. What we call that is infinitely many solutions, or you can just write the infinity sign. What that means is there's an infinite number of ordered pairs that you could plug in. So you could make up all kinds of ordered pairs and they would all work. So when you are doing the solving by graphing, there's three steps possibly. Step 1 you may or may not have to do. That would be solve for y so that you get it into y equals mx plus b. So again, you may not have to do that. If you look at number 1 and number 2, those are already in y equals, so you don't have to do that. Step 2 then is to graph each line. So when you graph it, again, one of those three things that we just looked at should happen. They should intersect one time, which is what happens most often. They could be parallel, so then you have no solution, or they could be the exact same line, so you have infinite solutions. So the last thing you need to do is to actually write your solution. So either an ordered pair, or if you want to write the 0 with the slash through it, or the infinity sign, or you can write them out in words. All right, so looking at number 1, it's already in slope-intercept form. So this tells us that we need to start down 8 for our y-intercept. And then we don't have a number, so we can put a 1 over 1. So up 1, right 1, you could keep going, or you can go down and left. It's going to be really important to draw your line straight. Some people will actually put all the dots possible so you can find exactly where they overlap, which is not that bad of an idea. So you could just keep counting all those dots. Okay, you do have to draw the lines. So some people wait to draw the lines until they know where they cross, which you can do that, but you do have to draw the lines. All right, our bottom equation, y equals negative 2x plus 1, means I start up 1 for my y-intercept. And then my slope is down 2 and right 1. And then I would keep going down and right until I find where they cross. But again, you still have to draw the line in. So that point right there, that ordered pair, is where I am looking for my solution. So it looks like that x value is 3 and my y value is negative 5. So 3 comma negative 5. So you need all three of those things to get full credit for each of these problems. You need 2 lines that are graphed, or 1 if it ends up being the same one, and then your solution. Most of the time that will be an ordered pair. Now, like I said earlier, you can check to make sure your answer is correct. The way you do that, this is x and this is y. You need to plug it into both equations. So if I plug it into the top one, negative 5 equals 3 minus 8. That is true. If you type in 3 minus 8, you would get negative 5. The bottom one, negative 5 equals negative 2 times 3 plus 1. You can type that into your calculator, or just know negative 2 times 3 is negative 6, plus 1 is negative 5. So that's how you check to make sure you have the correct solution. If we look at number 2, we have to start up 9 for our top one. And then our slope is 1/2. Up 1, right 2. We can go down 1 and left 2. Again, if you want to draw all of your dots in there to make sure you have them all. As long as you count them correctly, which I did not. There's all the dots you would have for that line. The bottom one, y equals negative x plus 6. So I start up 6. And then down 1, right 1, up 1, left 1, up 1, left 1. Draw your line. This is your ordered pair where they cross. So that ordered pair is negative 2 on the x and 8 for the y. So again, I'm not going to show it every time, but if you plug it in, 1/2 times negative 2 is negative 1 plus 9 does give me 8. The bottom one's a little bit confusing. You would do the opposite of negative 2, or negative 2 is positive 2 plus 6 does give us 8. So you know you did that correctly. I'm going to do a new video for page 5-2.